Okay, this is your doubt, correct?
So I didn't understand why they've taken raise to minus 120.
Okay, so this is the question. No? Okay,
Yes.
so the present value of a lump sum with monthly compounding. Okay, present value of a lump sum with monthly compounding. The manager of a Canadian pension fund knows that the fund must take a lump sum payment of Canadian dollar 5 million 10 years from today. She wants to invest an amount today in a guaranteed investment contract so that it will grow to the required amount. The current interest rate on GICs, that is guaranteed investment contract, is 6% a year, compounded monthly. How much should she invest today? Okay. So the manager of a Canadian pension fund knows that the fund must make a lump sum payment of 5 million in 10 years from today. You can see the screen, right?
Yes.
In 10 years from today, you require 5 million Canadian dollar. She wants to invest an amount today in a guaranteed investment contract so that it will grow to the required level. Then current interest rate on GIC is 6% a year, compounded monthly. Okay, fine. First of all, we'll calculate the effective rate of return. So effective rate of return, how do we calculate? Effective rate of return. So what is the formula, you remember? Effective rate of return?
Yes.
Hmm.
1 plus R upon n raised to n.
Nominal rate divided by n raised to n minus 1. So 1 plus 6% divided by what? N will be 12, right?
Yes.
Raised to 12 minus 1. Just calculate this.
— 6.167%.
6.167. So yearly, it is as good as, instead of saying 6% compounded monthly, I can say yearly 6.167. That's it. So you discount it, 6.167 percentage raised to 10. Calculate now.
Yes. Yeah, it's matching. 2748,365.
Okay. Now this you can use shortcut method also if you want. So you can go to the calculator, go for icon V. I'll show that. So here icon V is here, right? So I want to activate this second 2. So icon V is activated now. So nominal is what? 6%. So I'll type 6, enter, then downward arrow. Effective is what we need to calculate. Compounding per year is what? 12. Enter. Downward arrow, again downward arrow, and then effective is we have to calculate, right? Compute.
Yes.
6.17%.
Sir, which reading are we doing?
This is your doubt that she asked.
Okay.
So
I'll send mine as well.
yeah. So this is the question. So this is the question. Okay.
Okay, sir. Sir, I'll send in the group or I should send on your
Yeah, send in
chat?
the group.
Okay, sir.
Sent?
So 2 minutes. Sir, I have sent on the group. Sir, on page number 9 of that Shwezer book, it is
Shweta book,
written
page
that,
number 9. Fixed income.
yeah, no, points.
Bonds. Okay.
So they have written that when the manager has a complete control over the cash inflow and outflow of the fund or of the account, then the money weighted rate of return is the most precise or like more appropriate to measure the performance.
Yeah.
And when it is asked in the question, they are saying the time weighted rate of return is more.
When asked in the, if that condition is applied, then only money weighted will work. Otherwise,
But then they are saying that if a client controls the timing of cash flows
then
into and out of a portfolio,
time
which
weighted.
is the most so, but timing of the cash flows means control of the cash flows, right?
No, client is giving the money, right? So, for example, SIP. So that time, who knows what will be the market when he is giving the SIP?
Okay.
So market may not be at the right time at that time.
Okay. So I did not understand actually.
Okay. See, say for example, Shravan, you understood his question, what he wants to ask. Have you understood?
Yes, I understood the question.
Okay. See, let's say you are investing 100 and then it went up by 10%, it became 110. Then again, it went down by 20%. So just take 110 minus 20%. How much is it coming to?
88.
It would be 20 to 88.
88. So now if you can time the market properly, okay, if it is in your control, what you would have done is you would have probably withdrawn, sold here, taken away your 110.
Okay.
Correct. But provided you have the control. But then imagine you don't have the control.
Okay.
Then what you would have done? You don't have any choice only. Okay. So when you don't have any choice, so over here, see, somebody who is investing continuously. So geometric mean 2 years. Somebody investor who did not time the market. His return is what? 1 plus 10% into 1 minus 20%. Raised to 1 by 2 minus 1. So that will be 1.10 into 1 minus 20% is how much?
0.93. 80. 0.8. So 0.8.
0.8.
Yeah.
Yeah, 0.8.
Okay. 0.8. Okay, yeah. Then raised to
Half.
half.
It would be 0.93 something.
Overall, how much is it coming to?
0.619. 0.0619.
0.619. That means 6.19 percentage.
Yeah.
Okay. Now somebody who had control and he withdrew at the end of the first year itself, then he got 10 percentage no profit.
Yeah.
So if you have control on the on the usage of money, and also you should be able to predict the market properly. Otherwise, it will not work. It may go against you also if you are not able to predict the market properly.
Yes, sir.
Okay. Understood now? So SIP, why SIP is advertised? Because SIP is advocated highly because there you don't have to time the market, because practically it is not possible to keep on predicting the market rightly every time.
Yes, sir.
And that's why SIP works better there. Because let the market go up, let the market come down, you keep investing, and long term it will flourish.
Okay. Understood.
Okay, now you sent one question also. Okay, so this is the question. If your client controls the timing of cash flows into and out of your portion. Okay, it's the same question what you asked. Which of the following
Yeah,
is
yeah,
the
I
properly?
read it out to
This
you.
one only. Okay, when evaluating the performance. If the client is controlling, then it is better to go for time weighted. It is as good as SIP. In SIP, which return is better for you? Okay, time weighted. Fine, okay.
Yes,
That's
sir.
it, right?
Yes, sir.
Okay, now I'll continue. So I did till here quants. Still scatter plot we have finished, right?
Yes.
Then covariance. Now these all are important one. I have not taught this to you yet, right? Covariance, all these things. Okay. So covariance means how two variables are moving together. Okay. That means co-variance, co-movement, whether they are moving in the same direction or not. It is just telling you the direction, not the intensity of the direction. That means it says that, say for example, when you go for movie, you tend to eat popcorn. Will you always? That we don't know. Okay, you tend to eat popcorn. So whether they are moving in the same direction or not. So how to calculate this? So
So covariance.
yeah, covariance. Okay. So we'll take some numbers. See, x and y. So x, when x is 8, y is 12. When x is 9, y is 9. When x is 11, y is 8. Then when x is 15, y is 17. Okay, or 19. Okay. So now the formula for covariance is equal to summation of x minus x bar into y minus y bar divided by n minus 1. Okay, this is the formula. That means this deviation and this deviation, total deviations, okay, based on n, okay, divided by n minus 1. So remember last time I did I tell you why do we use n minus 1 in standard deviation? I told you, right? That degree
Yes,
of freedom. Same logic here also, degree of freedom. This
So
is
we
sample
cannot test the
variance.
whole population.
Yeah. So now x minus x bar. So you calculate x bar and calculate y bar. X bar is what?
Sir, X bar is 10.75
And y bar?
and Y bar is 12.
Okay. Now x minus x bar into y minus y bar. Okay, x minus x bar, if I sum it, I know it will come to 0, right? So what will I do? I'll do both together. Okay, so x minus x bar is 8 minus 10.75 into, so this 12 minus 12. So it
0.
will all come to 0. Then 9 minus 10.75, and this is 9 minus 12. Just calculate this.
5.25.
5.25.
5.
The next is 11 minus 10.75 into 8 minus,
Minus 1.
so, then 15 minus 10.75 into 19 minus 12.
29.75.
Add up all this.
34.
So covariance is 34 divided by 4 minus 1.
3.
So this is a
11.33.
positive number. Yeah. If the number is a positive, how much is it?
11.3.
11.33.
So if this number is a positive number, it indicates that they both are moving in the same direction.
Same direction.
If it is a negative number, then both are moving in the opposite direction. That's it. Nothing
Yes.
beyond that, anything it conveys to us. Okay. It's just telling whether both are in the same direction or not. That is called covariance. So if I want to know the intensity of the direction, that means, so when I say intensity, that is called as correlation. That we will see the strength of the linear relationship. Okay, the strength of
Plus
the
and
linear
minus.
relationship. Uh, First, we'll stick to covariance. Now, you do one thing quickly, just read all this. It's a very, very important concept. Okay, we will be using this in multiple subjects. Correlation, you don't have to read now. Till here, you read covariance. Just quickly read covariance. By itself, it does not have any units. Okay, if it is percentage, percentage square that way. See. And then correlation is the standardized measure of the linear relationship. Okay, so correlation, it measures the strength of the linear relationship. So strength of the linear relationship as in what is the chance or Yeah, what is the chance that if you know you are going for movie, then you will also uh, you will also have popcorn. Okay, so not only direction, now it is telling you the strength of that direction. So that strength, first we will do the sum, then you read this. Okay, correlation. So next one is correlation. Correlation is denoted as correlation or correlation coefficient, one and the same. Correlation is denoted as R. Okay. Yeah. So correlation is denoted as R. Correlation is equal to covariance of x comma y divided by standard deviation of x into standard deviation of y. Oops, I have to calculate standard deviation of x and y also not here. Okay. When we'll do all here in this number only. It's fine. Standard deviation of x and standard deviation of y. Now I have covariance. So standard deviation of x is what standard deviation of x will be. So standard deviation of x, what is
X
the
minus x bar the whole square upon
yeah,
n minus 1.
root of summation of x minus x bar the whole square divided by n minus 1. So now what I need is x minus x bar the whole square. So x is 8 minus 10.75 whole square. Just calculate this.
Minus 2.75 and 7.5625.
What is that? Continuation
7.5625.
2.75. 2.75.
The whole square, so it will be 7.5625.
7.5625. Right? Okay.
Yes.
Yeah. That is minus sign will go away. So here
3.0625.
9, 11, 15. Ah, how much?
3.0625.
Hmm.
0.0625. 18.0625.
Add up all this.
14.1758. 2.173.
Overall answer
Yeah.
is standard deviation of x. Shravan, you understood all the steps?
Yes, ma'am.
Okay. Now similarly, we'll calculate standard deviation of y. Standard deviation of y. Y bar is 12, right? 12. And y is
First one will be 0.
8, 9, 11, 15. First one is 0. Why is
So
0?
12 minus 12, no?
Why?
Yeah, it's 12 minus 12.
Why took for x value is it 8, 9, 11?
So that is
Yeah,
x,
12,
8, 9,
9,
11,
12,
15.
9, 8, 19. 12, 9, 8, 19. Okay.
First will be 0.
Hmm.
Second will be 9.
Hmm.
Third will be 16.
Hmm.
Fourth will be 49. .96. No. That is a standard deviation of y.
Okay, total how much it comes to?
Yeah. .74. 74 divided by 3.
Hmm.
4.96 it will come.
Okay, so now covariance. Not covariance, correlation. Covariance divided by standard deviation of x, standard deviation of y. Standard deviation of y is 4.96. Standard deviation of x is 2.173. Covariance of x comma y 11.3, no? It was 11.33. Calculate it.
1.049. Sir, it can't be. It has to stop at 1, right?
Yeah, it will be between -1 and +1.
Yeah. 6.
Shravani, you are also calculating all this, right?
Yeah.
So it
Yes.
will be 1 only, like it's 1.05. So we can take it as 1, right?
No, but how is it going to 1.05? Shravani, you are also getting the same numbers?
Yes, 1.0512.
No, all other numbers here.
Yeah, I was the same.
Okay. There is a shortcut way also. So now we see the
Second I can.
shortcut way and then cross check.
Second clear. So second data, right?
See, yeah. See here, this is a data function. Can you see this one, Shravani?
Yes, sir.
Yeah. So this is above 7, it is there, right? You want to activate
Yeah.
this upper function. So when you want to activate this upper function, you should click on this second. So second and then 7. Okay. So this is data function is activated now. So x01 is X01 is 8. 8. I don't know if it functions or not here online. Let's see. Enter.
So enter.
Then downward arrow. Then Y01. That means first number is 12. So I'll do 12. You can also do along with me. You have calculator, right?
Yes, sir. I'm
So
doing.
you also practice along with me. If I'm going fast, you tell me to stop. Okay.
Okay.
Enter. Then downward arrow. X02 is 9. Is 9. Enter. Then downward arrow. Y02 is also 9. Enter. Okay. Then downward arrow. X03 is 11. Enter. Downward arrow. Y03 is 8. Enter. Downward arrow. X04 is 15. Enter. Downward arrow. Y04 is 19. Enter. Now, keyed in all these numbers.
Yes.
Now you click on, you want to activate this stat function. So click on second and then 8. So that stat will get activated. Okay, so you are getting lean in your screen. Okay.
Yes.
Now you click on downward arrow. So N is 4, number of observation 4.
Yeah.
X bar is
X bar.
10.75. Okay, so you can use this shortcut also. The reason why I was doing all long cut is so that you understand what the system is or what the computer system is doing. Not computer, calculator is doing. Okay. So long cut is initially important so that you are able to imagine what numbers are doing. But later stage, you use shortcut method. Okay.
Okay.
So enter.
Sir, a standard deviation was wrong. Sorry to interrupt.
No, this is
This is a sample deviation.
This is sample standard deviation. Okay, sample standard deviation. Okay, and then next, which is 3.1. Let's see if it matches with our calculation. There is something wrong here.
So no, that is standard deviation of X, right? 3.1 is sample standard deviation.
No, it is sample only. No, we took n-1.
So then, which is the next value?
Next is population.
Oh,
2.68 is population. So this is wrong. So let's check. X minus X bar. That means here only. Something. Just calculate this once again.
So 14 also, if we take 14 divided by 3, it will be something 4 point. So its under root has to be somewhere around 2 point only. If it has to come around 3, then that should cross 9, right?
Yeah, something here must have gone wrong.
Okay. $7.5625. 3.0624. Yes, sir, the summation is the issue. It will be 28.75. That will be divided by 3.
So Shravan, you are not
Yes, sir,
doing this then at that
9.5.
time. You should have also calculated, no?
3.09. So actually it was my mistake.
No, you are calculating it
I
this.
forgot to no I forgot to do recall 4, I guess.
Okay. So the expectations you both should be doing, right? Okay. Okay. So 3.09 means 3.10 is okay. Then see, this is called population standard deviation, this symbol, okay? But practically we interchangeably keep using this. But here in this calculator, this notation stands for population. In case if you get confused ever, okay, I don't remember, I get confused. So all I remember is that bigger one will be sample standard deviation. That much I know. How? Because in sample only I'm doing -1. So always sample standard deviation will be bigger than the population standard deviation. Okay, sample standard deviation will be bigger than the population standard deviation. Okay, so in case if you forget, you can think like that. Okay, otherwise, this notation stands for population, and here this S is for sample. Then again, you do downward arrow. Y bar is 12. Is this right? Is right. Then downward arrow
Standard deviation of
4.9.
sample
This is
standard
sample standard
deviation.
deviation 4.97. I think this was right only. 4.9796 is okay here.
Yeah.
Then downward arrow. This is population standard deviation of y, which we don't require. This all number
Intercept.
you will learn in the last or second last chapter. Okay.
This
So
is
now,
intercept, right?
yeah. Now we will ignore those numbers, and here it is 0.74 r.
0.74.
So
Yeah.
r also we can calculate it directly like this. Okay. So here, just manually calculate and check now.
Yes, sir. 0.739. It's matching.
Yes, sir. 0.7392.
Okay. See, r will always be between -1 and +1. Okay, +1 means whenever you are going for movie, you are going to have popcorn, or whenever value of x is going up, y will also go up. Okay, whenever x is going up, y will also go up. That is called, so if r is equal to +1, it is called perfectly positively correlated. And minus, if it is 0, there is no correlation. If it is -1, then it is perfectly negatively correlated. Okay. Now you can read that book. Where is it gone? Now you read all this. So this is the notation, okay? They are writing like this, PXY. But you can write like this as well. Px comma y. That means correlation between x and y. Okay, but you think of this as R, correlation R. Okay. Hmm.
So,
Yeah.
so,
Yeah.
so I wanted to ask, are you taking offline now
Yeah, I will
in
be taking
Andheri?
tomorrow. Yeah, tomorrow. If you want, you may come.
No. I will come from 10th of September.
Okay.
So it's on like that. That is what I was asking.
Yeah, yeah.
Yes.
I didn't take for a few days, couple of weeks. In fact, I did not take.
Okay.
Uh, but now from tomorrow onwards, I'm going to
So
again.
Mihir's exam is on 24th, right?
Vinith's exam. Yeah, that's why I was
Vinith,
not
yeah.
taking training. Yeah, because I was doing all doubt solving for him last couple of weeks. Now
Okay.
from tomorrow onwards, I will start taking for Kaustu.
Okay, sir. I'll join from September. Yeah.
Yeah. Okay, Shawn, you read all this.
Yes, sir.
You're able to understand. You have any questions here?
No, sir, understood.
So variance is given. Stock A, stock B variance is given. Covariance is given. How to calculate correlation? So correlation requires what? Correlation requires covariance divided by standard deviation of x into standard deviation of y. So this is variance. So if I take the root of variance, I will get standard deviation. Covariance is already given 0.0058, and standard deviation of A will be root of 0.0028, root of 0.0124. Calculate all this now.
Point 98432.
So 0.9843. Okay. This is very close to
Yes,
1.
sir.
That means the
Positive.
yeah. So they are highly correlated with each other. The linear relationship is not only positive, but it is also very, very strong. Okay.
Yes.
Then spurious correlation, it's a theory. Spurious correlation means something, it refers to correlation that is either the result of chance or present due to changes in both variables over the time that is caused by association with a third variable. We can find instances where two variables that are both related to the inflation, where it exhibits significant correlation, but for which causation in either direction is not present. That means two things are connected to third things. And so there is some correlation between A and B because they both are moving because of C. That is one indirect correlation kind of thing. Also spurious means where you will not be able to find the reason, but you are finding that there is correlation. Example, imagine whenever I'm going out with an umbrella, it doesn't rain. That means what I'm telling you, there is negative correlation between me and umbrella and rain. But is it true? There is no scientific evidence, right? Okay. Or imagine whenever I invest, market comes down. So is there a scientific or is there actually any connection like that? Not necessary. That so that is called
No.
spurious correlation, which is without logic, but still it is the data shows that there is a correlation. Okay. Okay. Reading for probability trees and conditional expectations. Expected value. Expected means average value. Expected earning per share. So expected earning. See, these all are the. Just go through this question now. The probability distribution of earning per share for round stores is given in the following figure. Calculate the expected EPS. EPS probability distribution. Probability EPS. So this probability you consider as weight. See, if so many EPS are given, and if I'm asked to calculate the weighted or calculate the EPS, average EPS weighted, normally how I would have done? I would have done 1.8 plus 1.6 plus 1.2 plus 1 divided by 4. Let's calculate this. What happened?
1.4.
1.4. Now,
Yes.
now, is this only average or it is a weighted average? Hmm?
Only average, right?
No, there is nothing like only average. It is always weighted average. But it is not taught in school. Okay, at that level, it is not required also. But it is actually weighted average always. How you know? Because when you do divided by 4, that means one part you are dividing by 4. So you are automatically giving, so that becomes what, 0.25, correct? You are giving 25 percentage weight to each number. Okay, if I would have divided by 2, that means like two numbers, 10 plus 20 divided by 2. I'm giving 50 percentage weight. How? See this 50 percentage. So now it looks like it's a normal average, not weighted average. But no, 50 percentage of 10 plus 50 percentage of 20. Calculate 5 plus 10, 15. This is what I would have got here as well.
Yeah, 15.
So this is what weighted average, no? Equal weighted average. So when we say without weight, it is actually we are giving equal weight. Okay.
Yes.
Similarly, here also, this is 4 numbers are there. So 25%. You may cross check. So you just take 25% of 1.8 plus 25% of 1.6 plus 25% of 1.2 plus 25% of 1. You will get 1.4 only here.
Yeah, 1.4.
Yeah. And when I'm using this probability or weight or percentage, I'm not doing divided by. Why? Because divided by 4 is already taken care of in this 25%, right?
Yes.
Okay. Understood till here?
Yes.
So now the only difference is here they have told not to take equal weight, and they have given the weight. So I will take that weight. So 10% of 1.8 10% of 1.8 plus 20% of 1.6 plus 40% of 1.2 plus 30% of 1. Calculate now.
One 1.28.
Yes, sir. 1.8.
Okay. So that is it here. This is weighted average earning per share. So these weights are the probabilities. Then variance, this is another formula, can be calculated as a probability weighted sum of the standard squares from the mean. What does this mean now? We'll see. Okay, let's see this question now. Let's go through this question. Actually, here you don't have to see all the columns. Just the first 3 columns: event, probability, and return of A. Rest all should be a part of the answer, not part of the question. Just see only these 3 columns. Okay. Let's go through the question.
So which 3 columns did you say?
First 3. Event, probability, and return from A. Only read till there. Rest all should be a part of the answer.
So what are we supposed to calculate?
No, nothing. You read the question. I'm going to
Yeah.
do, you just read the question. So we have to calculate expected value, variance, standard deviation from the probability model. So based on probability, we are supposed to do now all this. First one is expected value. Expected means average, weighted average. So weighted average, how do we do? 30% of 20% plus
6.
50% of 12% plus 20% of 5%.
13.
Then that is the expected value. First question is done. Second is, what is the variance and standard deviation? Okay. So variance formula is summation of x minus x bar the whole square divided by n minus 1. But however, here probability is given. So this n is taken care of already. So let's see how to do that. See. First, we'll just calculate what is x minus x bar the whole square. X minus x bar. X is what? X is this 20. 20 minus x bar is
13.
13. I'm just removing percentage, okay? Because at the end you can suffix with percentage.
So it is 7.
Square. So this
7,
one,
7.
okay, this overall calculation is 7 square, no? But the probability is 20%. So it is 20% of this number plus, okay, because x minus x bar, it's all summation, okay, plus.
So it will be 12 minus 13
12
the whole
minus
square into 50.
13 the whole square into probability is 50%.
50%.
This is 20%, 50%.
Yeah.
Okay. Then next one is 5%, 5. 20%. Just calculate all this. This is summation of x minus x.
0.00147. Then 0.00005.
0.00. First one.
0.00147. First one answer.
Second one.
0.00005.
Third one.
0.00280.
Add up all this.
0.0028. So this is the variance. So under root will be standard deviation. 0.0529.
Shravani, you have got all these numbers?
Yes, sir.
Sure, right? If you want, you take time and do peacefully.
No, sir, got it.
This is the variance. So standard deviation is equal to root of 0.0028. Just calculate that.
Point 0.0529.
Just here you make sure that you don't include percentage, okay? Only here in this number, because you can include, but it will become little more complicated then. At the end, if you suffix directly with percentage, much easier.
Yes, sir.
Then probability tree. Expected, see, now this is probability of good economy is 60%. This is called probability tree. Probability of good economy 60%. And probability of poor economy 40%. Then if good economy is there, then probability of good result is 30%. Probability of poor result. Similarly, probability of good result is if poor economy happens. Probability of good result. 60%. Okay, now EPS is 1.8. Okay, here EPS is 1.8 and here EPS is 1.7. Here EPS is 1.3. Here EPS is 1. So now the question is, what is the expected EPS? That means average EPS. So expected EPS is equal to, now I have EPS here, 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 here. What I need is the probability. So probability, what will I do? Probability will be, see, when will I get 1.8? When 60% happens and then 30% happens. That means in order to reach to 1.8, both has to happen. That means joint probability. So both has to happen. So it will be 60% into 30%. That means 80% chance. Have you understood this one? 80%, 18% of getting 1.8. Is it fine?
Yes.
The next one will be 60% has to happen and then 70% has to happen. So that will be what? 6, 7, 6 are 42%. Then 40% has to happen and 60% has to happen. 6 fours are 24%. Or means plus. Or 40% and 40%. That is what? 16%.
Yes.
Just calculate all this.
One 1.55.
1.55. Yeah, 1.551. That is okay.
Yeah, okay.
That is fine. Understood this one?
Yes, sir.
Then Bayes formula. Okay. So Bayes formula is Bayes formula means if I say the probability of a person running is 30 percentage. That means the probability of a person not running
Not
is
running 70%.
70 percentage. Now, if a person is running, imagine probability of him being fit is, let's say, 80 percentage, and probability of him not being fit
20%.
is 20 percentage. The person is not running, he, let's say, he is, the probability of him being fit is maybe like not running, still fit, maybe 40 percentage. Okay. And probability of not fit is 60 percentage. Is it okay, this table? Okay. Now, see, what is Bayes theorem, Bayes formula? This is a little tough to understand. See, because somebody is running, so see, this is called unconditional probability. The one that is happening first is called unconditional. Unconditional probability. This is also unconditional probability. There is no conditions for it to happen, right? Either you are running or not running. Then if you are running, you are fit. Then this fit, you will be fit only if you are running. Then this is called conditional probability, because in order to be fit, you have to run first. Conditional probability. So these all are conditional. If you are running, then you will be unfit also. So if running has to happen 30%, then only 20% unfit. So conditional. Okay, these are conditional. Okay. So now suppose before we get into Bayes formula, let's find out something else. What is the unconditional probability of being fit? That is my question. What is the unconditional probability? Probability of
50.
Being
So
fit.
52.
What is
So
the
52.
unconditional probability of being fit? So unconditional means what now? So that means it has to cover
All the conditions of
this
being
part,
fit.
okay, and this part. So now this fit 80% and this fit 20% will happen provided the running is happening. And this, in order to be this fit 40%, this running has to happen. So if I say this running and this unrunning, not running is happening, that means fit will also happen. That means you can be fit 80% and 30%, or
Or
40%
non-running and fit.
and 70%. That means you run, you don't run. I'm covering what? Fitness. You
Yes,
run,
sir.
fit. You not run, fit. Shravani, you understood this?
Yes, sir.
Then this becomes what? Unconditional probability of being fit.
Probability of being fit.
So 24% plus 7 4 are 28%, which is what? 52%. Okay. Now in the same way, till clear, right? Shravani, you understood this?
Yes.
Now in the same way, if I ask you, what is the probability of what is the unconditional probability? What is the unconditional probability of being unfit? Can you try? Unfit. Unfit as in not fit. Not
48%. So
okay.
so it will be just 1 minus 52, right? You can do it that way as well.
Yeah, that is also fine. But right now, let's go with the long cut only.
Okay, so
How much you said?
48, like 30% into 20%
Uh.
plus 70 into 60.
Shravani, you got the idea how to do this?
Yes. Yes.
How?
So we're taking unconditional into not fit, and then
So you tell me
not
the
running
number.
into
So tell me the number.
30% into 20%.
Good.
Plus 70% into 60%.
Unfit. Yeah. Right. So this is what says 3 to the 6%, 7 6 are 42.
42.
48. You could have also done like this 52. That means remaining is unfit. But let's go with long cut only this way because it is more important to practice.
Yes, sir.
Okay. Now this is so far I have not come to base formula. No, but you understood the unconditional, how to find out unconditional, because many times it happens, not necessarily that B is dependent on A. Many times A can be dependent on B, or vice versa, as in vice versa. Both are possible. Okay?
Yes, sir.
Yeah. Now Bayes theorem is, or Bayes formula says this one only. That Bayes formula says, now here in this case, B is happening given A happens. This is written like this. B is happening given A happens. Okay. And this is probability of A. And this is probability of B divided given A. Given A means it is written like this, divided A. That means given A. So, and the joint probability is probability of A intersection B. This is the joint probability. Okay. So now probability of running happening first and then fitness happening second, joint probability is 24%. Or probability of fitness happening first and running happening second, still it will come to 24% only. joint probability will remain the same.
Yes, sir.
Okay.
Yes, sir.
So now here the formula is what you know. Now here comes Bayes formula. Bayes formula says I will make this conditional as unconditional, and I will make this unconditional as conditional. That means now this I will make this unconditional as conditional, and I will make this unconditional. I will make unconditional. I will make conditional unconditional, and condition unconditional. I will make conditional. That means this one I will make conditional. So probability of A by given B. So if B happens first, then what is the probability of A happening? That means if fitness happens first, what is the probability of running? You got the question?
Yes.
Okay,
Yes, sir.
so now the formula is what you know. The formula is okay. Probability of A by B is okay. Here denominator is unconditional probability of B. I will make this second part as unconditional. So probability of fitness is what now? Probability of fitness is 52%, right? So unconditional probability is what? 80% into 30 percentage. Just I'm copying this part.
Plus
Plus 40% into
40 into
70%.
70.
I'm deliberately writing like this all instead of directly writing 52%. Okay, why? Because you will come to know now. This is one group and this is one group. Okay. Now the denominator is now see let A happen first, running happen first, or and then fitness happens. The joint probability is 24. Or let fitness happens first and running happens. The joint probability is going to be 24 only. So that means the joint probability is what? 24 only. So 24, that 24 is what? 30 percentage and 80 percentage. 30 and 80. So that 30 and 80 percentage will come in the numerator. You write as 30 into 80 or 80 into 30, doesn't matter. Okay. So this is the joint probability. Okay. So now this 7, 8, 3 are 24 percentage divided by this is 52 percentage. Just calculate this. Just calculate 1 minute. I'll be back.
0.46. इसका 0.46 आ रहा है क्या?
Yeah, 0.46.
Okay. Your exam is in February or May?
Feb.
Feb.
When is yours?
November.
Yeah.
0.46.
0.46. That means 46 percentage. No?
Yes.
Okay. Now, have you understood this formula? Okay, let me try to explain this. See, probability of so basically it works like this. Let's say
So we are making the conditional probability unconditional. and we are making the unconditional one conditional.
Ah, yeah.
So I didn't understand the numerator part. Why is it again 18 to 30?
Okay. See, probability of initially this is probability of A intersection B is equal to probability of A intersection B is equal to probability of A into probability of B by A.
Okay.
Right, probability of A and then probability of B given A.
Okay.
So probability of A, okay, and into probability of B given A. Okay.
Okay.
So this is one part. Now probability of A by B is equal to, on this basis, or I can even say, see, probability of A intersection B is equal to, this step is okay, this step is fine.
Yes, sir.
Now I can also say probability of, B intersection A. That means both are same only, A intersection B or B intersection A. I can say probability of B, because this time B is happening first,
A
and then
by B.
probability of A given B. This is okay.
Yes.
So now, so you can imagine this, right? What I have written now.
Yeah.
Okay. So I'll just shortly write like this here. So this is probability of A, this is probability of B by A, and this is probability of A intersection B. I can write like this, or else I can also say probability of this is B, and this is probability of A by B. Okay. Probability of A by B, and then this joint one is probability of A intersection B. Finally, the total will remain the same, because let this action happen first and second action, or let second action happen first and first action. Total probability will remain the same. Okay, this is okay till here what I have written.
Yes.
A by B I am writing, or I'll write B by A. It's one and the same. I mean B intersection A and or A intersection B. So this is what I have written. So on this basis, I can say, so left hand side and right hand side all are equal only. Okay. Now what I want is probability of B by A. This is what I want. Probability of, sorry, no, what I want is A by B. This is what I want, right? This part, second part, not the first graph. I want the second graph. Probability of A given B, because B is happening first, no? So probability of A given B is this part. So I can say probability of A given B, this part. So probability of A given B is equal to probability of B intersection A divided by probability of B. This step is okay.
Yes.
Now probability of B by B intersection A is also equal to this part. Right? B intersection A is also equal to this part, no? Because this is equal to B intersection A only. So I can write here as probability of B, and here numerator I can write as probability of A into probability of B by A. Probability of A by B is equal to probability of B into probability of B by A. Is this step okay?
Yes, sir.
This step is also fine, right? So now this is unconditional probability of B. So unconditional probability of B is something that we are getting from here, 52%, which is what, 80 into 30, 40 into 70. 80% into 30 or 40 into 70. Okay. And numerator is what? Numerator is probability of, this is a joint probability. The joint probability of A and then the second one. So probability of A is 30% and the second one is 80%. So total is 24%, which I can write as 30 into 80. So the 30 into 80 is this one. So it will always be from this answer only, from the denominator only it will come up. Okay. It will always, it will always come up from the denominator only. So this will be 24% divided by 42%, which is what, 46. Sorry, this is 52 denominator, which is 46%. Okay. Now shortly, now let me tell you the shortcut way also. This is just derived because you said you did not understand. I was deriving all this. Now shortly, if I tell you, okay, I'll draw this graph again. So probability of running, not running 30-70. So this is the original question. Running 30, not running 70. Then probability of being fit is what? 80, 20, 40, then 60. 80, 20, 40, 60. 80, 20, 40, 60. So probability of fit and not fit. Probability of fit and probability of not fit. So now when I want to know what is the probability of being fit, that means I'm making fitness unconditional. No, what is the probability of running given you are fit? That means you are already fit, I'm saying. So that means fitness will come as the unconditional.
Unconditional.
What is the probability of running given you are fit? So all you have to do is, given you are fit, the denominator will be unconditional. So unconditional is what? So unconditional will be this entire thing as well as this entire thing I will take. Both the sides fit I will take. So it is 30 into 80, 30% into 80%. Okay. And plus 70% into 40%. Is it okay? Denominator. Numerator, all you have to do is what is the probability of running, right? So running. So running, I will take this entire joint probability. So 30% into 80%. Is it okay?
Yes, sir.
Okay, which is 24% divided by 52% which came to how much? 46%. Now next question. What is the probability of running given you are not fit? So you are not fit is what? Unconditional. So unconditional probability of not being fit is what here? That means this one, and this one. Fine, okay.
Yes.
So not fit. So this will be 20. So I'll write it here itself. It will be unconditional. No? Unconditional, it will be 20% into 30% plus 60 into 70. Okay. And in the numerator, the question is what is the probability of running? So running is what? This one. This joint probability I will take, which is 20% into 30% into 20%. And whatever answer comes, that is it. Fine, okay.
Yes.
Now another question. So this is for second question. Then third question. Third is what is the probability of running, I said fit and fit. Okay. Now, what is the probability of not running? Given you are fit. Given you are fit. What is the probability of not running given you are fit? So given you are fit is what? Unconditional. So fitness unconditional is what? This part and this part. So 30 into 80 divided and then 70 into 40. Okay. So 30 into 80 or 70 into 40. It's white color. And then not running, probability of not running. So not running will come here. So 70 and 40%. So this is here.
So 0.538.
Okay, denominator is what? Denominator is 24 and
24 plus 28, 52.
How much?
0.538.
So 53.8%.
8%.
Okay. The next one. What is the probability of not running given you are unfit?
Unfit. Okay.
So given you are unfit. So unfit is the unconditional. So unfit means which one? I will take this one and this one. So 20 and both are 20, right? So this is 30. So 20 into 30 percentage
87.5%.
plus
70 into 60.
60 into 70. Yeah, 70 into 60.
Yeah.
60 percentage into
Sir, and the
30.
numerator will be 60 into 70 only, right?
Yeah. Not running. So not running will be
So the final answer
not
is 87.
not running is this one 60 into 70.
87.5.
Yeah. So finally, how much is it all coming to? 7 6 are 42 percentage divided by this is 6 7 48 percentage. How much is it coming to? 42 percentage divided by 48. How much? Hello?
Sir,
Hello?
87.5.
Fine, you understood this one now?
Yes, sir.
Yes.
Base formula. If you read, it will be little complicated, but you will get, if at all sum comes, it will come like this only. You can try this one. You take this as the homework. If you are not able to, then I will do it. Okay.
So we'll stop.
Fine, yeah, we'll stop now here.
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
Or do
Bye,
you
sir.
want to try? Shall we do this one also and finish it up
Okay.
now itself? Or okay, will you try this one?
So instead
Okay.
of that, we should solve the model quiz, right? Module
No,
quiz.
that also you try. Probably this may be too difficult for you. This one, if at all you are able to do it. First one, second one you try. Second one also both you try. If you are not able to, it's okay. Fine. Okay. Yeah, I think okay. Fine. We'll stop now here. You just try this question, but
Okay,
okay.
sir.
Okay, we'll stop.
Thank you.
Thank you, sir.